Okay, so starting with group 1. Group 1 is the farthest to the left or farthest to the right? Farthest to the left. Group 1 starts with hydrogen, lithium, sodium, potassium. All those are in group 1s, okay? So group 1 are called the alkali metals. Hopefully this is a name that you are familiar with or have at least heard before. Okay, the alkali metals typically have a silvery color. Okay, hydrogen is an exception here. Hydrogen is a gas, so it is not a metal. Okay, so the alkali metals begin with lithium and run all the way to francium. Okay, hydrogen is not an alkali metal. These are pretty soft metals. These guys are not found in nature as a free element, so you won't walk around outside and find a chunk of sodium metal. Okay? It's usually bonded with something else. Right? They don't survive, or they don't appear in nature often as free elements. Okay, these group 1 metals are extremely reactive. They bond with lots of things. Okay, and that has to do with their number of valence electrons, which we will talk about later, but they have very, very, very reactive properties. Okay, they like to be around everyone. They're the socialites of the periodic table. Okay, they react very, very highly with water, most of the time in an explosive reaction, all the time in an explosive reaction. They are reactive because they have what we call one valence electron. Have you heard the term valence electron ever before? You have? Okay, good. Does anyone know what it means? Yeah, Carolyn.
How many electrons are in the outermost shell?
Perfect. Yes, very good. How many electrons are on the outermost shell? So these are electrons available for bonding. Okay, group 1s only have one electron available for bonding. So do you think they would rather give up that electron or try to gain 7 other electrons? Give it up, right? It's easier to give away 1 friend than to gain 7 friends. Okay? You guys are killing me. That's a joke. Okay, all right. Just for me. Okay. So valence electrons are the number of electrons in their outer shell. They want to be able to give away that electron rather than gain 7 more. Okay, it's difficult because bonding structures or chemical bonds like to have 8 electrons. Elements like to have 8 electrons surrounding them. That's what we call the octet. Okay, and they like to have an octet. They like to be happy with 8 electrons. Okay, we'll come back to this in just a second. If I have time, remind me. Let's move on to group 2, the alkaline earth metals. So here's an example of our alkaline earth metals. It might be helpful for you if you have your periodic table out in front of you so that you can just see the elements we're talking about. I'm going to list them up here, but I think it's easier and more helpful for you to see them in their periodic table form. Okay, so we know where group 1 is. We know where group 2 is. I think it's just a little easier to see them on the periodic table than in a list form in front of you. Okay? These take on much more real metallic properties than group 1 does. They are stronger, denser, harder than the first group metals, okay, or than the alkali metals. Okay, these have higher melting points than group 1, okay? So every time we're comparing higher, lower, whatever, we're basically saying in comparison to group 1. So these have typically higher melting points, which means they have stronger metallic bonds holding them together. So it takes more heat for them to start melting. Okay, they are now less reactive than the alkali metals. Although they're less reactive than the alkali metals, they are still too reactive to be found in nature. Okay, they still like to bond with things too much to be found by themselves in nature. Okay, that's why group 1, you don't see it in nature very often because they're extremely reactive. They like to bond with everything. So it's hard to find them by themselves. These guys are the same way. Although they are less reactive than group 1, they still are too reactive to sit by themselves. These guys have 2 valence electrons. Surprise, surprise. Group 1 had 1 valence electron. Group 2 has 2 valence electrons, which means they have 2 available for bonding on the outermost shell. Okay, here's a lovely little picture of calcium. Okay, so we didn't name the transition metals with group numbers. That's okay. But the transition metals are what your book would consider groups 3 through 12. And where do the transition metals sit on the periodic table? Yeah, in the middle, that big chunk that's taken out right in the middle. Okay? These transition metals have very typical metallic properties. Okay, and the transition metals kind of follow less clear patterns than all the other groups do. Time, but you can put them down again if you want or not. It doesn't really make a difference. Okay, but here's some of our metallic properties that we went over. There's a couple new ones. Okay, so we talked about the first 3 and the last 2, right? Those 2 that are stuck in the middle, they're less reactive than previous groups. That means they like to be kind of left alone. They like to be found by themselves. And then because of that, many of them you will find in nature as a free element, okay, or existing in its pure form. That's what we mean when we say free elements. It can exist by itself. It's okay being alone. The transition metals, they carry a variety of number of valence electrons. The transition metals don't follow very clear patterns when it comes to valence electrons or things like that. Okay, groups 1, 2, and then our group 3 through 8 follow very, very clear patterns. But the transition metals don't do that. They're a little bit more varied. Okay, so there's not a good way to necessarily describe the patterns of the transition metals. They vary a lot more. All right, let's look at the group 16 or group 6. We're jumping over here to the oxygen family. Okay, so this is our group 6 on our periodic table called the chalcogens. Okay, your book would call them group 16. We call them group 6. I promise after this chapter we won't get them confused anymore. We'll be dealing exclusively in our groups. So just bear with me for just this chapter, okay? This is the oxygen family. These are pretty reactive. It's a pretty reactive group, okay? They like to bond. Okay, the oxygen family contains elements like oxygen, sulfur, selenium, tellurium, and palladium. Okay, so within that group, they take on a couple different properties because within the group you see a shift between nonmetal, metalloid, and metal. Okay, they have all kinds of different properties that are found within that group. Okay, so although sulfur is a nonmetal, it's still a solid at room temperature. Okay, whereas so is all the rest of those elements. Oxygen's the only one that's a gas at room temp. Okay, group 6 or group 16 likes to form compounds with metals. Okay, they like to bond with things on the opposite side of the periodic table. most of these compounds that are formed are not soluble in water. What's it mean to be soluble? Yeah, Miguel, what do you think? Yeah, soluble means it's able to dissolve. So if they're not soluble, that means they can't dissolve in water. Okay, so most of these compounds cannot dissolve in water. Okay, they are not soluble. Okay, so these are the nonmetals, metalloids, and metals within group 6 or 16. Okay, we told you there's a lot of different properties going on. 3 of them that are nonmetals, 1 metalloid, and 1 metal. Okay, so group 6 has quite an array of different properties going on. They do share one thing. They have one thing in common for sure. What do you think that thing might be? Yeah, very good. Valence electrons. They have, oops, sorry, we missed our man-made one. Okay, but they have 6 valence electrons because they are in group 6. Okay, that's why we labeled them group 6. They have 6 valence electrons. And then, sorry, right above that, we have a man-made element that's in group 6 as well. Okay, that number, 35, that means there's 35 elements. Sorry, I'm not sure why it says atoms. There's only 35 man-made elements. Okay, I will put a little star by that number, something to remember. Okay, there's been 35 man-made elements. And on the periodic table on the wall, those are the ones that are outlined in white. They're really hard to see. They kind of look like empty boxes from here, but they're outlined in black and they're just white letters. Okay, those are the man-made elements. On your periodic table that I handed out, there's no difference. Okay, but on the one on the wall, you can tell the difference. Okay, so only 35 elements have ever been man-made. Their groups, yep, 7 or 17. The halogens are my favorite group. I don't know why, but they are. Okay, the halogens are my absolute favorite. They, well, we'll go through their properties here. They're the most reactive nonmetals. They like to bond with anything and everything. Okay, the halogens most of the time form compounds we call salts. And that doesn't necessarily just mean sodium chloride salt, right? Sodium chloride is an ionic compound with a group 1 element and a group 7 element, sodium and chloride, but there's other ionic compounds that are under the heading of what we call a salt. Okay, so that's what group 7 normally forms, some things called salts, with either group 1 or group 2 elements. Okay, so you'll see lots and lots of ionic compounds called magnesium chloride, calcium chloride, sodium bromide. All those things are salts between group 1 or group 2 elements and group 7 elements. Okay? All right, group 7s can be liquids, gas, or solids. And surprise, surprise, they have 7 valence electrons. Can anyone explain to me why they would be so reactive? Brayden, what do you think?
Because they can react with all those ones with only 1 valence electron.
Yeah, they only need 1 valence electron to be happy, right? They have 7 electrons, they only need 1. They can take that from a lot of different elements, okay? So they like to take electrons from anyone and everyone all the time. Very good. Okay, they're usually not found alone, or they're usually not found as free elements for that exact reason. They are so reactive, they bond with everything. Okay, that's why sodium and chloride is NaCl. Sodium gives up 1 electron, chloride takes 1 electron. They're a little match made in heaven, right? Okay, group 1s and group 7s are little lovebirds because they have 1 electron to give, 1 to take. Okay. These guys don't react with water at all. Yeah, 8 or 18. Very good. Group 8 or 18. The noble gases. Do you think this group has a variety of phases? Solids, liquids, and gases? No. It's in the name, right? They're noble gases for a reason. They are gases. Okay, these guys are not reactive. They don't like to be around anyone or anything. They like to hang out by themselves. All right, they are all gases at room temperature, hence the name. And they have a full outer shell, which means they have how many valence electrons? 8. Yes, they have 8. Okay. A full outer shell, sorry, I went one too far ahead. A full outer shell means they have a full octet. They have 8 electrons. They don't need to bond with anyone. They don't want to bond with anyone, so they don't. Okay. All of these guys are used in what we consider neon lights. They put out fluorescent and neon type properties. We're not going to go into that too much, but just something fun to know. So although we call them neon lights, there's different noble gases that exist within those. It's not just neon. Okay, let's quickly talk about some other parts of the periodic table. We hit group 1, 2, 6, 7, and 8, so let's talk about just some of the other ones. Okay, the lanthanides. Can anyone tell me where the lanthanide series is? On the bottom. Yep, on the bottom. These are one of the 2 extras that are on the bottom. Okay, and sometimes they start with La, sometimes they start with Ce. Okay, on your periodic table here, they start with Ce. So it starts with group 58, atomic number 58, and flows to the end. Okay, that's called the lanthanide series. They are shiny metals, and typically they act like group 2. The series right below that, or the group of elements, the period of elements right below that is called the actinide series. Actinides. Okay, lanthanides and actinides. These are atomic numbers 90 through 103. Okay, they run on this bottom line right here. They are radioactive, and some of them are found naturally on Earth. So some of them are too reactive, some of them are just right. So on your periodic table, I would go ahead and draw a little line, basically showing where these 2 rows should be inserted. The top, the lanthanide series, should be inserted after atomic number 57, La. And the bottom row, the actinide, should be after AC, number 89. Okay, so you can just draw a little line up there if you want. This is not something that necessarily has to be done. It just might be helpful to you to see where those fit in. It also helps you remember which series is which, right? The top series is called the lanthanide series because it's after lanthanum. Not an element we work with very often. Okay, and the actinides are after actinium. You can see that on the classroom periodic table a little bit clearer since most of those are those white letters. Okay, and those mean man-made. So most of the actinide series is man-made. Okay, and I'm going to show you a quick picture of what this, what the periodic table would look like if you inserted the lanthanides in the actinide series. Okay. Okay, if you put those in their place, this is what it would look like. Okay, and which is just generally too big to fit on a regular sized piece of paper, not quite as clear to read, so they just pulled them out and put them below.